be, and hope everyone is being safe, staying safe with the strange environment we're now living in here. Quick thing, for those of you who don't know us at Glass 3, we're located in Langley, British Columbia, Canada. It's a suburb of Vancouver located on the west coast of Canada. We are a glass brokerage company that procures products from all parts of the world and provides them to our customers throughout North America. This ranges from glass for railings, canopies, skylights, insulated units, shower doors, etc. The more heavily fabricated the item is, the better price we usually are and are able to secure for you. Our company is approximately 17 years old, but our experience is much more than that. We've got people that have been in the business for over 40 years and are trained to secure the right product and arrange the logistics to supply to your warehouses or job sites in a timely manner. Another main strength of ours is the relationship that Glass 3 has in the marketplace. We're able to call on many industry professionals to assist us in answering your questions through their vast resources. An example is today we are able to secure Mark Jacobson for this webinar. Mark is the North American market manager for Kuraray, based out of Northern Ohio area, and is an expert in the world of interlayers. Mark will be providing us some background information on the company, as well as technical information about specific interlayers that you can relate to for your projects. Also, Mark will share some resources that are available that may help you in the future. I also wanted to thank Greco Railings, as they assisted us in sending out information on this webinar to many different architects. We look forward to making this a regular occurrence and secure other industry professionals in the future. With the relationships we have developed, we feel it will be worthwhile for all of us. This will include fabricators and laminators, etc., that you may be familiar with, but we can assist you with in getting further information. Please note that during this presentation, your microphones will be muted. If there are any questions, please send them in the chat box available. Mark will either address them during this presentation or in the question and answer period following. In case you miss anything and want to share this presentation with your team, we will be recording this and the video will be posted on the Glass 3 and Greco Railings website for future reference. Thank you for your time, and a pleasure to introduce Glass 3 to you. Now I'll leave it with Mark.
Thank you, Ralph. And with that, I will mute everyone. Okay, can everyone hear? Well, I've just muted everyone. If you have any questions during the presentation, you can unmute your microphone and you can ask the question, or as Ralph said, you could put it in the chat box and we will answer it that way. I would like to thank Glass 3 Enterprises and Greco Railing for helping organize this meeting and this web seminar and getting the information out so we could have a good attendance for it. Today I'm going to talk about selecting interlayers for specific applications. This is going to be how you would select an interlayer and the reasons why you would select the different interlayers for given applications. I have my email address on the first chart. I'll have it on the last chart. If you have any questions, please feel free to send me an email. We could get you the other contact information, such as phone number and so on, later on. So before we get into the part about the glass and the interlayers, let's talk about Kuraray itself, because a lot of people are not familiar with the company Kuraray. The company was founded in 1926 in Japan, and the origin of the name, the first four letters, the Kura, it comes from Kurashiki, which is the area in Japan where the company was founded. The last three letters, Ray, that's for rayon, which came from the first product that Kuraray manufactured. So you put them together, you get Kuraray. So Trosifol is the Kuraray interlayer business, and you can see how it evolved over time. Kuraray in 2004 bought the HT Troplast business from, and that started their venture into interlayer, and that was their PVB business, and that's where the Trosifol name comes from. In 2014, so next month it's going to be 6 years, since Kuraray purchased the DuPont GLS and vinyls business. And along with that came products such as Butasite PVB, as well as Century Glass and Century Glass Expressions, and the whole portfolio of the Interlayers from DuPont. So now the whole thing is combined, and it's all under our Trosifol brand of products. The brand names are still the same. I have crossed out the Butasite because our PVB portfolio is now all called Trosifol. So there are several applications that we'll be talking about today where laminated glass is used. First of all, we'll talk about some overhead applications such as canopies and skylights. You need laminated glass to reduce the risk of falling glass as well as fall through. Guardrails. Guardrails is a big topic these days as the codes have changed, and we'll spend a little bit of time on what's going on with the codes and standards for guardrails. Security, both man-made and natural threats. We'll talk about natural threats through this presentation, and then at the end there's a little addendum where we'll get more into forced entry and man-made threats. Comfort, and in talking about comfort, I am referring to acoustics, so we'll talk about that. And then finally, aesthetics and durability. This would be some colors and printing on interlayer and edge stability concerns that may come up. So I'm going to put this up at the beginning because this is what we're going to learn about today. How do you select an interlayer? So this is a little flow sheet that we've come up with that gives you an idea of how to select the appropriate interlayer. Through this presentation, we'll go through the reasons why you would select the particular interlayer, and then we'll return to this at the end so you can come back and see why we make these choices. So as far as laminated glass, I'm sure most of you know what laminated glass is when you have at least two pieces of glass and at least one interlayer. The interlayer is there to retain the glass if breakage occurs. The types of laminated glass I'm going to talk about today are those made with PVB or polyvinyl butyl and ionoplast, which is the generic term for Century glass. Now, if I were doing this in person, I'd have samples that I could hand around and you can feel what the interlayer is actually like. You can see on the picture there, the interlayer, the interlayer is exposed on about the bottom inch of the sample. The rest is laminated with glass. So with PVB, it's a soft interlayer originally developed for the automotive industry in the 1930s. You can see if it's not supported by glass, the interlayer itself cannot support the structure. So it's not really a structural type interlayer. Now with ionoplast, it was invented in the 1990s after Hurricane Andrew struck Florida, and it was developed initially for improved hurricane resistance and windblown debris resistance. So it's 100 times stiffer than PVB. It's got 5 times the tear strength, and it can maintain the load even without the reinforcements of the glass. So this may allow for thinner glass construction. That may be important if you're doing larger glass, because as you go larger and larger, it gets heavier, and if you can reduce the thickness, that can help offset some of the weight. So this is what it looks like with a Century glass interlayer. And you can see it stays up by itself. You can deflect it. It just returns to the same place. And you'll see more videos of actual glass breakage as we go along through the presentation. But that's just a little bit of background as far as getting some understanding of the differences between the interlayers. As far as the codes, where you're going to find a lot of information, if you go to IBC Chapter 24, you'll find the overhead glazing types information there. You'll find information on handrails and guards. It'll talk about safety glazing for shower enclosures and other hazardous locations. There's information about floors and elevators and so on. One thing I do point out is that tempered glass is considered safety glazing. And in some applications, such as shower doors, you can use tempered glass. Other applications, like in overhead applications and in most handrail applications now, you have to use laminated glass. So both laminated and tempered are safety glazing. Heat-strengthened glass is not. And an annealed glass is not safety glazing. It has to be a laminated heat strengthened or laminated annealed to meet those requirements. As far as overhead is concerned, the codes call for a minimum 30 mil PVB interlayer. And the key word there is minimum, because in a lot of cases, when it's engineered, it won't meet the requirements. So in these two pictures here, you see large point-supported glass. That's in Phoenix. So with the heat, you may get some sagging, and you'd have to go thicker with the glass if you didn't have a stiff Sentry glass type interlayer. This is a good example where you have exposed edges and point support, and you'll see in the next chart and video what happens when you have that type of situation. What you'll see here is a stiff PVB. It's our Trosifol ES and our Sentry glass, each being impacted with a falling object. It's 100 kilos or 220 pounds dropping from 4 feet. And this is your stiff PVB, and you can see how it tears from the point supports. And obviously that is not a safe situation. Now with the ionoplast, same type of test, and this is a thin ionoplast. It's only 35 mil, 0.89 millimeter, and it does not tear, it stays up. So let's say if a worker were on a canopy doing something and he tripped and fell, there is safety built into that type of system. Railings and guards, I mentioned earlier that there's been a lot of change in the standards over the past half dozen years or so with railings and guards. In IBC Chapter 24, it says glass used in handrail, guardrail, or guard section shall be laminated glass constructed of fully tempered or heat-strengthened glass. It used to be either laminated, fully tempered, or heat-strengthened, or you could use fully tempered glass. There's an exception to that where you can use tempered glass if there's no walking surface below or if the walking surface is permanently protected. So if there's a canopy around the building, you may be able to use tempered glass because if the glass falls, it protects the people below. Personally, I don't like that exception because if the glass falls and you're the unfortunate person on the 20th floor, there's nothing protecting you from falling over. So I personally am not crazy about that exception. Now, in the Canadian standard, CSAA 500, which came out in 2016, they have a table in there that talks about the risk of non-retention after glass breakage. And you can see with tempered glass, it's a high risk. When you get a flexible interlayer like a standard PVB, you can see it only goes to a moderately high or moderate risk, and you'll see why in a minute. When you get a stiff interlayer, and the standard defines a stiff interlayer as something with a Young's modulus of over 300 megapascals. So, you know, a Sentry glass would fit into that category. It becomes low risk. So what does it look like? This is your half-inch tempered glass after impact. You see how it breaks. I think most of you are probably familiar with that. It's supposed to break into small pieces, and it does. But if you look at some of these big chunks that are agglomerated before it hits something else, if a half-inch piece of glass that size hit you on the head, it would not be pleasant. If you put film on it, it holds the glass together very well, but now you have one piece of glass falling. It's very dangerous. PVB, this is very similar to what you saw earlier. Once the glass is broken, there's nothing there to reinforce the PVB and allow it to stand up. It falls over like a wet blanket. And now with the Sentry glass, and this is a thin Sentry glass, only 0.35 thick, it deflects and it stands up, and it provides protection not only for the people below, but it will provide protection for the people on the elevated surface. Now, another thing has occurred going from IBC. I hear some feedback. Let me make sure everyone's muted. Okay. So going from IBC 2015 to 2018, the change occurred in how you could install a railing without a metal cap or without railing connecting three pieces of glass. In IBC 2015, if you wanted to install a system like that, it required building official approval. In IBC 2018, it requires the system to be tested and the glass to remain in place, and it goes by ASTM E2353. So we've started doing some testing on the glass, and the previous videos were with 6 millimeter glass. This is 8 millimeter glass with the 60 thousandths Trosifol PVB, and after impact does exactly the same thing that the thinner glass did. It falls over like a wet blanket. So then we've done it with Sentry glass, again with 8 millimeter glass. It's impacted and it did not break. We were pretty impressed by this. Now, that being said, you can't go out and say, okay, I'm going to specify 8 millimeter glass and 60 mil Sentry glass interlayer, and I don't need building official approval. The railing supplier has to test the system, and the system has to pass. The reason being, there's a lot of torque when you impact that glass, and let's say if the system isn't designed properly where it either can fall out of the shoe, or if, let's say, the anchors aren't long enough and the whole thing falls over, it all has to be tested. So someone like Jim Ellsworth may be a good resource to find out what the status of their system is for something like that. Couple other things I like to point out when it comes to railings, because this comes up and architects bring this up, and I like to see glass get installed and everyone be happy with it. So ASTM C1172 is a standard for laminated glass, and in that standard there's a table that shows how much misalignment you can have for your glass, depending on thickness of glass and size. And in a typical railing type situation, you may have as much as 7/32 of an inch misalignment by the standard. Your clients will not be happy with that. In that standard, there is a section, 8.5.3, that talks about some laminated glass applications, such as point-supported glass and balustrades, where the edges are exposed. Tighter length and width tolerances may be requested by the customer, and you consult your supplier to determine their capability. So that's a place where Ralph and his team could come in and, if they're aware that this is the application, make sure that the suppliers are meeting the tolerances. And I've got a picture here of a very nice glass edge, so it's something that you should be aware of. The other thing that you should be aware of when installing laminated glass into a shoe, and I'm going to mute all again. When installing glass into a shoe with laminated glass, alkaline Portland cement is aggressive towards laminated glass. So we do not recommend the use of Portland type cements or grout for that matter, because people have started using gypsum-based grouts on exterior, and it's not meant for areas where it could get wet. So we do not recommend those types of things. There are some polyurethanes and modified two-part systems on the market that are available. There are also dry glaze options that are available. It's important to make sure you're using the right material for compatibility. Security is an area that comes up in a couple of ways, both man-made and natural. This first video is it's a video showing a demonstration that we did at a trade show in Latin America. This is a mock-up of a jewelry store case. This particular structure, it's quarter-inch annealed glass on both sides with a 90 mil Sentry glass interlayer. And you can see it's buying time. As we get to the end of this presentation, we'll get more into the details of security and how much time you can get with some recent testing. So the baseball bat didn't work that well, so now he's going with a sledgehammer. And I was recently in on a presentation where the architect giving the presentation said the average for a person trying to break in that they'll give up is 14 seconds. So, you know, he spent a little more time and he was not through it. So glass can be designed for forced entry resistance. Missile impact performance, this is important in areas with windborne debris. This is the reason Sentry glass was invented originally. So what you'll see here is a 9-pound 2x4 being shot at 50 feet per second or 34 miles per hour. The glass breaks, but it stays in place, and that's the objective. You want the glass to fill the opening. They'll pressure cycle this glass 9,000 times to make sure it stays there, because if the glass stays there, you avoid the damage on the inside of the building. You may have to replace a piece of glass, but by not having to remediate all the damage from water getting into the building and wind getting into the building, you save a lot of money that way. You know, when you see a hurricane, everyone's out there putting up plywood and things like that. That's what you see on the news. But if you're building a high-rise or, you know, you have some sort of curtain wall system, you're not going to be boarding it up. So you need something built into it, and you've got to make sure that the systems have been tested and are compliant. One area that's coming up more and more in the past couple of years is acoustics and sound reduction, especially in areas with high population density. You know, there are standards in New York. Toronto just adopted some, I think, in October of last year. It's becoming more of an issue, and laminated glass helps reduce sound from one side to the other. As a matter of fact, now we're going completely opposite of some of the things we've just seen. Instead of a structural type system, you're looking for something softer. And there are specially formulated PVBs available that are better than standard PVBs, and that will help improve your acoustics. The picture on the left is a system that Modern Fold is promoting that has an STC of 51. This picture is the Hoxton Hotel in Chicago, right on the L tracks, and you'll see a little video of this in a couple of slides to see how well the sound control laminated glass performs. So this is what your thought process may be when you're designing some acoustic glass. You can look at a monolithic piece of 10 millimeter glass and get an STC rating of about 33. Now, if you put in laminated glass with two 5 millimeter pieces of glass and a standard PVB, you could increase that performance to a 35. If you put in a laminated glass with an acoustic PVB and the 5 millimeter glass, you can go up to 38. So you go 5 points from a monolithic glass to an acoustic PVB. Well, let's say you don't need all of that performance and you're getting a little bit thicker than you'd like to be. You can get better performance by going a little bit thinner on the glass, 3 millimeter glass with the acoustic PVB versus a standard PVB. So there's different options you can go through. If you have questions about that, we can consult with you on it. We have an app that you can put on your phone that will help you select types of glass construction to meet acoustic ratings. So why does this happen? Basically, in glass, there's a coincidence dip. And the coincidence dip is determined by if you take the thickness of the glass and divide that into 12,500, you'll see where the coincidence dip. So this is actually for 10 millimeter glass. You can see the coincidence dip is right around 1250 hertz. And you can see most of the area, it's pretty close, except here. So when we blow this up, in the area from around 1,000 to 2,000 hertz, there's quite a difference in acoustic performance. So while we were talking 3-point improvement versus a standard PVB and 5-point versus an acoustic PVB, that's a weighted average. If you go to this particular frequency range, you're talking about 10 points from monolithic glass to an acoustic laminated glass. And 10 points, 10 dB, is basically you're cutting half the sound down by going to the laminated glass with the acoustic PVB. So it's very significant in this range. And really the range of hearing that we're most sensitive to is in the 1,000 to about 5,000. So it's cutting out a big chunk of sound in the range that we're quite sensitive to. So I showed you the picture of the Hoxton Hotel from the inside. This is actually what it looks like from, you saw the outside. This is from the inside. I stayed there last year, and it's right on the L. And if anyone has ever been in Chicago and seen the L, it kind of sounds like this. Yep, let me restart that. There we go. Obviously, with the window open, you're going to get pretty much all the sound, but you close the window. And you've got a room where it's quite comfortable to sleep. There's still a little bit of low frequency sound that comes in. The low frequency sound, you can accomplish more reduction if you increase the mass of the glass, but it's very effective in reducing the sound and making for a quiet and comfortable environment. Colors. Colors comes up quite often. Trosifol has many different colors. We have decorative colors and the standard architectural colors. An area that we have somewhat of a unique product offering is in our opaque colors. We have an opaque white and an opaque black. The opaque white is outstanding if, let's say, you had a conference room and you wanted a writing surface but didn't want anyone to see any read-through from the other side. It's an excellent material for that. It can be used in partitions or barn doors. In addition to the opaque white, we have 3 other opacities ranging from 80 down to 65% down to about 21%, depending on what the application is. I find that some barn doors, let's say like in hotel rooms, they're starting to use more laminated glass with some level of translucency separating the bathroom from the sleeping area. And I think the more opaque you can get with that, the better off you are, because if people sleep at different schedules, then you don't want to have a big light coming through from the bathroom. Just summarizing, the vibrant colors that we have, as well as our black and white portfolio. Clarity in optics. Century glass has been known for its ultra-clear appearance since it was invented. And if you look at the picture on the bottom right, you see the difference between a Century glass and a standard PVB. Standard PVB has a tendency to be yellow. And this comes in when you're using low iron glass, because you're paying extra money to use the low iron glass. You don't want to impart any off color into it. Now, there is PVB that is ultra clear also. It's our Trosifol ultra clear product. It's almost as clear as Century glass. So if there are no structural requirements, if it's a pretty much standard storefront captured type application where you're using low iron glass, using a Trosifol ultra clear would maintain that appearance that you want to achieve with the low iron glass. Weathering is another area of concern. We've had our Century glass out in Florida for over 20 years now, and you can see a lot of edges exposed, and we don't see delamination or fogging. We've done accelerated weathering tests, and these two pictures are showing some results of that. This is a 3,000-hour salt spray test that was performed, and with the Century glass, you see the edge is still clear. This is our Trosifol ES, the extra stiff material. You can see what happens with PVB. You get a little bit of clouding, and Trosifol ES is better than a standard PVB, but there's still some issues with clouding along the edge because PVB has a tendency to absorb and suck up moisture, for something that's going to have an exposed edge, Century glass is better. It also occurs when you have butt glaze system. My colleague Ron, who is on the call, lives in Florida and got some of these pictures in Orlando at the airport, and you can see what happens in a butt glaze system. It's very good as far as water resistance. As far as moisture is concerned, you get some ingress, and then you start seeing some delamination. Here it's pretty horrific where, they obviously didn't seal the point very well, and you see this crystallizing appearance. Actually, we have a question. What do you recommend for interior arena conditions at cross-aisle concourse for helping to mitigate sound or echoes? Well, if sound is the biggest concern, the echoes are going to be tough because you still have glass. You've got glass surfaces, so that's going to be difficult to mitigate. But as far as sound transmission through the glass, the best would be getting like the Trosifol SC, the sound control interlayer, would have your highest STC rating, so you would reduce sound going through it. Some of the other things that we do glass calculations and modeling. What you see in the picture is a finite element analysis of a point-supported system. You can see where the points are on the glass, and you see where the stress is and things like that. We can help support in the writing of your specifications. We have our master spec online, and you'll see a picture of that in a couple of slides. We have compatibility data for various sealants and coatings and frit. We're global. We have technical support in all regions and sales support. And as I mentioned earlier, there are apps available for your phone. There's one on structural. You can do some glass calculations on your own. If you're trying to figure out what you want in your railing, you can get pretty darn close to it with the app. We have one for the sound control, and there's also one for light. I got another comment here. What about exposed vinyl in an interior setting to reduce echo? That would be like a film on the glass. We really don't do that in our portfolio. I don't know if someone else would have something like that, but that's not something that we would offer. Typically, you wouldn't have a PVB exposed. It's just too soft. It would get damaged. It would get dirty, and you wouldn't be able to clean it very well. There's some other products. We have a film that could be laminated on. It's a hard coat polyester, but I don't think that would have a big impact on the acoustics. Been through a lot of background about the interlayer, and we get back to where we started, and that's how do you select the appropriate interlayer for a given application. So it starts out, is it going to be outside or inside? And from a Kuraray perspective, if it's outside and it's exposed edges, we're always going to recommend a Sentry Glass or a Sentry Glass translucent white. It is available in translucent white, which is quite popular for things like canopies and partitions and things like that. I know Greco uses it quite a bit in partitions. If it's structural and outside, we still recommend Sentry Glass. If you're inside and it's structural and it's not low iron glass, then a Trosifol extra stiff, a stiff PVB is okay. Stiff PVB has its stiffness properties up to 30 degrees C or 86 degrees Fahrenheit. So that's why we say if it's an interior application, it's okay, but we wouldn't recommend it for outside. And you can see how you would go through this decision tree to come up with the selection for an interlayer. If you have any questions, obviously you can contact us and we can help you with that. I mentioned that we're on Master Spec. We're in Spec Link also, but this is our Master Spec file. You can download the Word file and cut and paste right out of it. I mentioned earlier when we were looking at the forced entry that we'd go into a little more detail towards the end. It's a little addendum to the presentation. Because security has come up quite a bit. It's come up certainly in the United States a fair amount around schools. We get questions around embassies, things like that. And so we've been doing a fair amount of testing in the past couple of years. The ASTM F1233 test, and you can see the sequencing of tests there. And you can also see where it's got a couple of sequences with where you get to a propane torch, and that becomes quite difficult for things like interlayers because they're plastics made out of hydrocarbons. But we'll see how things performed in a couple of minutes. And the 5AA1 test, this is some of the testing that's done on school type, branded school glass that's out there, and you can see the type of testing. They'll shoot it and throw bricks at it and kick it and so on. And this is the type of sequencing that they go through, and you can see how much time it goes through. So with that 5AA1 test, you can see really what you want to find out from your client is, what is your objective? How long do you need forced entry resistance? Because you can see, you can go from nothing, to anywhere from 51 seconds up to over 13 minutes, depending on the construction. If you notice this is lower than the 180, it's not because it didn't perform as well, but this one actually tore after a certain amount of time, and this one never tore, so they just stopped the test. So it would go longer than that. But, 13 minutes is a long time for people to be out there. I would imagine in most situations someone will be there to help mitigate the situation. So on the ASTM F1233, I pointed out the propane torch because of this. When you went to 270,000 Sentry glass, this actually made it through the propane torch in the first round, and then got to the third test protocol on the second round. So, I mean, you can design some glass that has a lot of forced entry and intrusion resistance type capability. Again, the key is, what does the client want? What are their needs? I did want to mention, for those of you that need credit, we do offer several AIA courses. I know they've been accepted in the various provinces in Canada. If we would send a certificate, and you can get credit in Canada also. This is on our website if you have any desire, either web seminar in this current period of time or in the future time for someone from Kuraray to come in and make a presentation. We could certainly arrange for something like that. And that's the end of the formal presentation. If there are any questions, you could unmute and ask questions or put it in the chat. I do see a question now. Let's see, what restrictions are there when using a frit pattern and Sentry glass on the number 2 surface? Sentry glass actually adheres quite well to frit. There have been projects, and at this point I can turn on my video, but there have been projects where Sentry glass has been used on 100% frit coverage, so that isn't a concern. The other thing that we've just introduced in the past year is our Sentry glass Extra. It's the next generation Sentry glass. It is called SGX. That one we actually got a trademark on. We never got a trademark on SGP, so we call it Sentry glass. But SGX has very good adhesion to the air side of glass as well as the tin side. So if there are any concerns about adhering to the air side, you could specify using the SGX material, the Sentry glass Extra. Are there other questions? Just unmuted everybody, so if you have any questions, go ahead.
Ensuite, je suis comme un séminaire de
What's that? Can you speak a little closer to the microphone, please? Okay, I don't hear any questions right now, and I don't see anyone chatting. Again, if you have any questions, you can contact me. My email and phone number are up on the slide now, and we certainly welcome questions. I thank everyone for participating today, and I especially want to thank the folks at Glass 3 and at Greco Railings for certainly putting in the effort to organize this session. Have a good day and stay safe.
See you again further.
Thank you.
Thank you.
This is the door.